So this topic is all about making the game more interactive by adding items and devices that the player can interact with. So like doors, collectible items. So let's break down what the topic covers and what each concept means. So first is creating interactive devices like doors. So in this part, we'll discuss about adding objects to the game that the player can control, starting with doors that can open or close. So the idea is to let player interact with these objects by pressing keys. For example, when they approach a door and press a button, the door should open. So this is done by programming certain objects to respond to specific player actions, making the game feel more alive. And adding collectible items, so we'll make items in the game that the player can collect. So think of it as picking up keys, coins, or other objects that will be useful later on. So this involves detecting when the player comes close to or collide with an item, so they can pick it up. So collecting items also adds to the game's state, which means that game will remember the player has that item even after they move on. And the next topic would be tracking items using inventory system. So to keep track of what player collects, we will build an inventory. This is where all collector items goes, sort of like a digital backpack. And the inventory system is important because it organizes items so that the player and the game know what the player has collected. For example, if they pick up a key, it gets stored in the inventory, allowing the player to use it later when they need it. And next step would be organizing code with MVC, model view controller architecture. So to keep the code neat and easy to manage, we'll use a MVC setup. MVC stands for model view controller and is a way to divide code into three parts. Model is this is where data is stored. In our case, it includes things like the list of items the player has collected. When it comes to view, this is the visual part of the player sees on the screen, such as inventory display showing what's been collected. And the last one, controller part connects the player's actions to the game's data and visuals. For example, if the player picks up a key, the controller updates the model, which adding the key to the inventory, and changes the view, which is showing the key in the inventory display. And the last step would be using the inventory in the gameplay. So the last step is linking collected items to actions in the game. For example, if the player has picked up a key, they can use it to open a locked door. So this is what makes the items functional, letting players use what they have collected to solve puzzles or open new areas in the game. So why we are building this? These interactive elements help create a more engaging experience for players. So by collecting items, players gain a sense of progress. So by using those items like unlocking doors, they feel they are affecting the game's world. So this chapter brings together all the foundational elements we have covered so far, creating a game world where player can interact with objects, collect items, make real use of those items as they explore the game. So first topic would be creating an interactive door in Unity. So in this setup, we'll discuss about creating a door open device script that makes a door move door object move when the player interacts with it. So first we decide how much the door should move when it opens, and we use variables to keep track of whether the door is currently open or closed. And when the player interacts, we move the door to open or close it based on its current state. So first step would be setting up the door object. You add a cube object to the scene, position it like a door, and give it a scale that makes it door size, and then creating a door script. So in the create a C# script uh, called door open device, and draw uh, drag and drop this script onto the door object, and then the code device. So we are using dpause. This is a vector 3 variable, which means it has three values x, y, z. It defines the direction and the amount of door will move when it opens. So by marking dpos with the serialized field, it shows up in the inspector, allowing you to set it directly in Unity without making it public. So this is helpful because it can adjust the door movement without changing the code. And we have a open. So open is a boolean true or false variable that keeps track of whether the door is currently open, which is a true, or closed, which is false. So if the door is open is true, and the door moves back to its starting closed position. This is done by subtracting dpos from the uh, door's current position using the transform dot position minus door's position. If the door is closed, so open is false, the door moves to its open position. This is done by adding door position to the door's current position using transform dot position plus door's position. And finally we have open is equal to this line of code. So this toggles the open variable so that it switches between true and false every time operate method is called. So after next step would be setting up the door movement in Unity. So after attaching the script, you go to the inspector where you'll see doors position with fields x, y, z values. For a downward movement like the door sinking into the floor, you could set the door position to 0, 2.9, and 0. This moves the door down just enough to disappear, leaving us a small part visible. And so currently the door moves instantly between open and closed positions. If you want to make it smoother, you can use a method called tweening, which animates movement over time. Unity plugins like Lean Tween or DOT tween can help make this movement smooth and polished. So the next step would be to make this door open and close with a key press. So the player needs a script that calls the operate when a specific key is pressed. So once set up, you'll have fully interactive door that opens and closes based on players' actions. So this setup is adaptable. You can change the door position or add extra effects like sound to make the door's movement fit any game style. So next, in this section, you'll add a script to make sure the player is close to and facing a door before interacting with it. So this feature is commonly used to make interactions more realistic and avoid accidental activation of nearby devices. So for that, we first create a device operator script. So that script will check if the player is near an interactive device like a door, and if they are pressing the interaction key. So let's go back to the code. Device operator. So in the device operator script, we have a radius which determines how far the player can be from a device to interact with. You can set it this distance in the inspector, and get down this checks if the player press the C key to interact, and physics dot overlap sphere creates a detection sphere around the player to identify nearby colliders within the specified radius, and the send message, yeah, send message operate sends an operate command to nearby objects asking them to execute any operate method they might have. So the don't require receiver option prevents errors if an object doesn't have this method. And so to add realism, will add a code to check if the player is facing the device. So this ensures interactions happen only when the player is both close and looking at the door. And for that, we calculate the direction vector. So this line of code calculates a vector pointing from the player to the device. So we keep it horizontal, uh, but by setting hit position dot hit position dot y to the player's y position, so no vertical angle affects the direction. And we also use a dot product check. So this checks if the player's forward direction where they are facing aligns with the direction to the device, and we uh, yeah, so this means that the player must be facing within a specific angle towards the device to interact. As so after that, you attach the device operator script to the player. Now the door operates only when the player is close and facing it, creating a more intentional and immersive interaction. So by using this approach, we ensure that only devices in the player's view and within a set distance are triggered, allowing more flexible and natural interactions with other types of devices too. So to create an interactive color changing wall display, uh, it's so that display will respond to the player input and change colors randomly when activated, just like the door we implemented, we discussed about. So for that, first we need to create a wall monitor. So first you add a cube to the scene to act as a display. Place it so that one side sticks out slightly from a wall, and we create a color change device script. Attach this script to the cube uh, which was set up, and so in this device color change device script, we have a operate method. This method is what allows us to trigger the display's color change. We use the same method name, operate, because this is how the device operator script interacts with any device. Whenever the operate method is called, the display's color will change randomly. And inside the operate method, we create a new color uh, object with random values. So here random dot range 0f 1f generates a random floating point value between 0 and 1 for each RGB, which is red, green, blue component of the color. So each time this line runs, a unique color will is created, as each component is randomly chosen between 0 and 1. And next step would be applying the color to the display. So once we have a random color, we apply it to the display's material by using this line of code. So the get component renderer access the object's renderer, and the dot material dot color changes the material's color to the new random color. So remember that Unity uses color values between 0 and 1 for RGB, rather than the usual 0 to 255 range used in most other softwares. So now when the player moves close to the display and presses the designated operate key, the display will change color. So this example uses the same method operate as we did with the door. The device operator script activates both types of devices in the same way, which means we can reuse the interaction method with other devices as well. So the color change device script allows our display to change color each time it's activated. This code is designed to be easily reusable and can be adapted to various interactive objects. So Unity's color objects uses a normalized values 0 to 1 for RGB, which we set randomly for the different colors. So in this way, we now should have a interactive color changing monitor in the game, adding more functionality and engagement to the scene. So next topic is setting up the physics-based interactions with the player. And so to create a physics-based interaction with the player and a pile of boxes, we'll go through a simple setup and add a small amount of code to make these uh, boxes scatter realistically when the player bumps into them. So first you create the boxes. So start by adding a few cube objects to the scene to act as boxes. Arrange these cubes in a stack or pile. Uh, for example, you can create 5 cubes and stack them into 2 tiers so they are ready to react to the player movement. And the next step would be adding physics to the boxes. So each of these boxes needs a rigid body component to enable physics. So Unity's rigid body is what makes a object responsive to forces, collisions, and gravity. So to add the rigid body, you basically select a box, go to add component physics, and you'll find rigid body, and repeat this for each box in the stack. And next step would be coding the push effect in the player script. So now we'll add code to the relative movement script from previous topic to make the player push the boxes when they collide. So let's go back to the relative. So in this a push force variable is defined as 3.0f, which determines how strongly the player pushes the boxes. You can increase this value if you want the boxes to move more forcefully. And so on controller collider hit, this method runs automatically whenever the player with the character controller component collides with another object. So hit dot collider dot attached rigid body gets the rigid body attached to the object the player collided with, if any. So if the collided object has a rigid body and is not set to kinematic, a mode that disables physics, it will be moved by the player. So if the object has a rigid body, we use body dot uh, body dot velocity to apply a velocity to it in a direction the player was moving when they hit it. So we also hit dot move direction multiplied by push force calculates the velocity, and hit dot move direction is the vector that points in the direction the player was moving, and multiplying it by force push force applies that movement to the box. So when you start the game and approach the stacked boxes, when you bump into them, they should scatter realistically due to the rigid body and push force applied. You can adjust the push force value in the inspector for different effects if you want to see more or less applied to the boxes. So by adding a rigid body component to an object, Unity's built-in physics engine can simulate realistic collisions and responses. And the player's relative movement script detects collisions with the on controller collider hit, checks if the object has a rigid body, and applies a push force to make the boxes move. So this simple setup allows the player to interact with the physics enabled objects just by running into them, providing a dynamic response in the game environment. So with this implementation, you can easily extend this technique to interact with other objects in the game, adding more responsive and engaging gameplay elements. So next topic is operating a door with a trigger in Unity. So to set up a door that automatically opens when the player enters a specific area, which is called a triggerer, and closes when they leave, we'll use Unity's built-in trigger detection. So let's break down each step and the code involved to make it simple. So first step would be you create a door and a trigger object. So add a door object in Unity to fill a gap in the wall. For example, we can create a door using a cube and position it to fit where the door should be. And Next, you add a trigger area. So create a cube object and place it in front of or around the door. This cube will act as a triggerer zone, which means if it will detect when the player enters or exits. And in the inspector of this cube, for this cube, check for each trigger option in the collider component that makes it a trigger zone rather than a solid object. And set the layer to ignore raycast, which can be found in the top right of the inspector, so it doesn't block other interactions. And also remember to turn off cast shadows under the mesh renderer component, which prevents the invisible trigger area from casting shadows in the game. And to make the trigger area visible in the editor but transparent in the game, you can also create a new material and set the rendering mode to transparent, and choose a color and reduce the alpha value to make it semi-transparent. And you will just drag this material onto the trigger cube in the scene view. And next step would be setting up the trigger detection code. So you need to create a script that will open and close the door when the player enters or exit the trigger area. So we'll create a script called device triggerer. uh, so this script will control any devices like doors that responds to trigger events. So we have here we have a we have targets. This array holds the objects that the trigger will affect, like doors. Even though we'll add only one door, we use an array so it can control multiple objects if needed. And on trigger enter. So this method is automatically called when another object like the player enters the trigger area. It loops through each target and sends a activate message to trigger the activate method on each target. And we also have a on trigger exit. So this method is automatically called when the player leaves the trigger area. It sends a deactivate message uh, to each target, which triggers the deactivate method on the target. And after that, just drag and drop the device trigger script onto the trigger cube. And in the inspector for the trigger object, you can set the size of the targets array to the number of objects you want to control. I think in our case it's one. And just drag the door from the hierarchy view into the slot in the targets array. And the next step would be updating the door script for automatic operation. So now that the trigger can send activate and deactivate messages, we need to update the door script to respond to these messages. So here the activate method opens the door. If open is false, meaning the door is closed, it moves the door by the defined offset, which is the door position, and sets open to true. In the deactivate method, this method closes the door. If open is true, meaning the door is open, it moves the door back by subtracting the offset, which is the door position, and sets open to false. So yeah, that should be it. And ensure that the device trigger script is on the trigger object, and confirm that the targets array has the door as its target. And when you enter the play mode in Unity and approach the door should open when the player enters the trigger volume, and close when the player leaves. This setup provides an automated, immersive way to interact with objects based on the player's proximity and offers a versatile structure of various devices or triggers uh, in the game. So next topic is collectible items. So let's go through the process of creating collectible items in Unity, where the player can pick up items by colliding with them. So for that, so first step would be setting up the collectible objects. So start by creating a sphere in the scene to act as a collectible item. Adjust the sphere's position so it floats at around the player's waist height, and set the scale of the sphere to something small so it looks like a small object rather than an obstacle. And enable trigger and set layer. So in the inspector, find the collider component on the sphere and check each trigger. This setting allows the sphere to detect when the player touches it but won't block the player's movement. And change the layer of the object to ignore raycast in the top right corner of the inspector. This keeps the item from interfering with raycasting, which is often used in aiming or other interactions in games. And the other step would be applying a distinctive color. So to make it visually distinctive, create a new material, select a color and apply this to the material to the sphere. uh, since this item is small, you can turn off shadows for cleaner look. This can be done under the mesh renderer in the inspector. And the next step would be writing the collectible item script. So you need to create the code that will allow the player to pick up the item by touching it. So make a new script called a collectible item and attach it to the sphere object. This script will manage what happens when the player collides with the item. So collectible item. So serialized field string item name. This line defines a variable called item name that holds the name of the item. Example health key. So the serialized field part makes this variable visible and editable in the inspector, allowing us to set each item's name individually. And void on trigger enter. This function runs automatically when another object enters the item's trigger area. So in this case, it will trigger when the player collides with the item. So in this function, we have a debug. I think it's you can add a debug message which will print a message to the console that includes the name of the item collected. And destroy this dot game object will remove item from the scene once the player collects it. Using this dot game object ensures we are destroying the entire item game object, not just the script. So some of the important things to remember is it's important to specify this dot game object, because it if we used only this, it would remove only the script component, not the whole item. And in Unity also, other thing is in Unity, select the items in the scene and you'll see the item name field in the inspector. There you can assign unique names for each item, such as health or energy. And the next step would be customizing and creating prefabs. So setting unique names and colors, you need to customize each collectible items by changing its item name and assigning a unique color, which is the material. For example, you could use a blue for energy or red for health. And creating prefabs. So in Unity, as you know, drag the items from the hierarchy to project window to create a prefab. So this prefab acts as a template, allowing you to place copies of each item throughout the level easily, and place the prefab instances in the scene. You can drag the instance of the prefab into the scene, placing them whenever you want the player to find the collectibles. So final step is run the game, move the player to touch the items and watch the console output. You should see the debug messages showing the item name, confirming that each item is detected and collected. So right now the collecting items only logs a message and destroys the item. This code is I removed the debug dot log message. So you'll be adding on to that setup to add these collectible items to an inventory system. That's what this line of code is doing, enabling real gameplay effects. So the collectible items use ease triggerer to detect the player's collision without obstructing movement, and the on trigger enter is used to recognize when the player touches an item and to perform actions like logging and destroying the item. And prefabs allows us to reuse these collectible items across the scene easily. So with this setup the player can interact with various items across the game. The code structure allows you to customize different items and prepare for more complex inventory tracking in future steps. So that's all.